Okay guys, let's have a look at the homework from the other night. So it's just all practice on right angle triangles and Pythagoras and finding angles. So find the value of y in the triangle below, give your answer correct to 2 decimal places. Okay, so hypotenuse C, opposite A, and adjacent B. Okay, so I could look at using Pythagoras, but the problem with Pythagoras is that I don't know C and I don't know A, and you can't solve an equation when you have two unknowns, so I'm not going to be able to do that. Okay, so I'm trying to find y, and this I know, and this I know. So if I eliminate the hypotenuse, don't worry about the hypotenuse, and just look at opposite and adjacent. So where is that table book? I should think I have a version of it, do I? Hang on. Okay, so opposite and adjacent are A and B. So it's that one there, it's tan. Okay, so we go the tan of the angle is A over B. The tan of 55 is the angle. A is y and B is 6. So we're trying to isolate the y, and at the moment it is being divided by 6, so we need to do the opposite, which is multiply by 6. And if you multiply by 6 on the right, you have to multiply by 6 on the left. Right, so those 6's take you to the right, and then just left with y. And 6 times the tan of 55. Okay, so I'm getting 8.568888, and a few more digits. Give your answer correct to 2 decimal places. Okay, so there's the first, there's the second, then we stop. We look at the next number, and we see, is it big enough? It's an 8, so it is big enough. So it'll make that 56 or 57. So y is 8.57. Alright, for part B, it says hence use Pythagoras to find the value of x. Okay, so that was A. Now B is c squared equals a squared plus b squared. So c is the hypotenuse, which is x, we don't know it. A is the opposite, which is y, which we've just figured out to be 8.57 squared. And b is 6 squared. So x squared equals, so I'm just going to do this whole thing, so 8.57 squared is 73.4449 plus 6 squared. So I'm getting 109.4449. And then take the square roots here and here, and we get x equals, square root of my answer is 10.46159, and it goes on. Again, it's 2 decimal places, so 1, 2, and stop. Look to the next number. Is it big enough? No, it's not. So x is going to be 10.46. And for C, it's find the measure of the third angle. Okay, so that should be actually nice and easy. This is 55, this is 90. So 55 plus 90 is 145. And then 180 minus 145 is 35. That's part C. Now down here, this looks very similar. So here's your hypotenuse, C. This is your opposite, A. And then we have the adjacent, B. So find the value of y. So this is the one we're looking for again. And this we don't have. So we'll go with A and B again. So it's going to be the same as it was in the previous one. It's going to be tan. So the tan of the angle equals A over B. The tan, the angle is 35, equals A, which is y, over B, which is 8. Same thing, trying to isolate the y, it's been divided by 8, so we need to do the opposite, which is to multiply by 8. And multiply by 8 and then divided by 8 take each other out. But if you multiply by 8 on this side, you need to multiply by 8 on this side. Okay, so y equals 5.60166. So 2 decimal places is 1, 2, stop. Look at the next number. It's a 1. Is it big enough? No, it's not. So we leave it at 5.60. Again, hence use Pythagoras. So part B, C squared equals A squared plus B squared. So C we don't know, it's called X in the picture. A was Y, and we now know that Y is 5.60 squared, and B is 8 squared. Okay, so 5.60 squared plus 8 squared. I'm getting 95.36. And then we take the square roots and the square root. And we get x equals the square root of the answer, which is 9.765244. Alright, again it's 2 decimal places. So try that again. 1, 2, and stop. Is the next number big enough? Next number is a 5, so yes it is. So that will push. So we get x equals 9.77. And then the measure of the third angle again is nice and easy. So C, I have 35 plus 90, 125, and then 180 minus 125, 555 for the third angle. Okay, and the last one again, similar, same job. So opposite the right angle is the hypotenuse, C. Opposite the marked angle is the opposite, A. And then this one over here is the adjacent, B. Part A, find y. Okay, so this is what we're looking for, and this is what we have. So this one becomes our eliminated one. So B and C. There's B and C, cosine. Okay. So for part A, we do cos of the angle is equal to B over C. The cos of 52 is equal to B is Y over 26 for C. Okay, same maths here again. The y has been divided by 26, so we need to multiply by 26, and the multiply and the divide cancel each other out. But if you multiply on the right, you need to multiply by the same thing on the left. So y equals 26 multiplied by the cos of 52. Okay. C 16.00719 blah blah. Again 2, so 1, 2, and we're going to stop. Look here, is it big enough? Yes it is, that will push. So it'll go up to 16.01. Second one's the same, Pythagoras. So we have c squared equals a squared plus b squared. C is 26. A is the opposite, which is x, which we don't know. And b is the adjacent, which is y, which we now know to be 16.01. Okay, so 26 squared is 676. X squared is x squared, and 16.01 squared is 256.3201. We're trying to isolate this, which means this thing here needs to go. It's a plus 256, so we need to do minus 256.3201 to get it to cancel. If you minus that on the right, you have to minus that on the left. X squared equals 676 minus your answer is 419.6799, and then we square root, so we get x equals, square root of my answer is 20.4860. Goes on again, 2 decimal places, so 1, 2, and stop. And this is big enough, so it will push, which means x equals 20.49. And the last one's to measure the angle. What's the angle? 52. Okay. So we have 52 plus 90 is 142. And then we do 180 minus 142, and we get 38. Okay, that's all the answers to the homework. And what we're moving on to today is actually a new chapter. So it's chapter 17 in your book 2, coordinate geometry. And 2 relatively straightforward concepts here today. The first thing is coordinates, okay? So they want to know the coordinates of the pineapple. Okay, so the way you do coordinates is you always do x first, and x is your left-right movement, and then y goes second, and y is your up-down movement. Okay, so I'm trying to get to the pineapple, so I start here, and I do right-left first, so I go 1, 2, 3, 4, 5, okay, and that's where the pineapple is. So it starts with a 5. And then to get to the pineapple, I have to do 1, 2. So my up-down movement is 2. You put a comma between them and brackets around them. Okay, for part 2, it's here I'm looking at. So back to the center. 1, 2, 3, 4, 5, 6, 7, 8. From my left, right. And then up 1. Okay, next, where is that? Oh, here it is up here. Okay, so 1, 2, 3, 4, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, next we are over here. So starting here, I just go 1 to the right, and then I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up. And then the broccoli. So across it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then up 1, 2, 3, 4, 5. Okay, so you do your, in this case it was all right and up, but it could be left as well if there was negative numbers. So do your right left first, that's your x coordinate, and then your up down second, which is your y coordinate. Okay? Now, the first formula that you're going to do in coordinate geometry is the distance formula. Okay, this is the page in the table book, you can see it over here, and it's not called distance, it's called length. See it there? Okay, so length and distance are the same thing. It's just not called, it's called the distance formula pretty much everywhere, but in the table book it's called the length formula. Okay, and this is the formula. Another way they can ask for length or distance is just see these straight line brackets. Those straight line brackets are another way of saying length or distance. Okay, so there's kind of three ways of asking it. They can either say distance, they can say length, or they can simply use the straight line brackets. Okay, so let me show you how to do it. So the first thing you do is, like what I said a second ago, the first number in these brackets is an x and the second number is a y. First number is an x, second number is a y. And then we call them, so the first point is ones and the second point is twos. Okay? So from up above, you go to the table book and you get your formula x2 minus x1 squared plus y2 minus y1 squared. Now all you have to do is put the right number in the right place. Okay? So start with my square roots and a bracket and x2. Okay, so there's x2, which means that's x2. So 3. Minus x1 is 2. Close bracket and squared. Plus new bracket. So y2. y2 is there, it's 5. Minus y1 is 1. Squared. Okay, then we'll simplify. So 3 minus 2 is 1 squared. And 5 minus 1 is 4 squared. Then we have 1. And so 1 squared is 1 and 4 squared is 16. So that's going to be the square root of 17. So if it's a square root that works out, you normally do work it out. And square root of 17 is not going to give you a whole number, so just leave it as the square root of 17. And if I do the square root of 17, just to give you an idea, I get 4.1. So there is 4.1 units between point A and point B. Okay, try another one. So first thing you do is you label it. So this is x and y and x and y. These are your ones, these are your twos. Next thing is it's asking for the distance formula. So you go to your table book. You remember that distance and length are the same thing. And you write down your formula. Okay, so x2 minus x1 squared plus y2 minus y1 squared. Now you just put the right number in the right place. So x2 is 2 minus x1 is minus 1. Okay, we'll deal with that in a second. Plus y2 is 5 minus y1 is 1. Now, this double minus is weird, right? Essentially, do you remember I told you that the only operation you don't have to write down is multiplication? So what we have going on here is a minus multiplied by a minus. And hopefully you remember that that's a plus. Okay, so we can rewrite this as 2 plus 1 squared plus 5 minus 1 squared. Okay, so sometimes in this formula, because you have minuses in the formula, if you have a minus in your point, you end up with that double minus, okay, but it's fine. 2 minuses make a plus. So that's 3 squared plus 4 squared, which is 9 and 16, which is the square root of 25. Now that is one that works out, that's 5. So there's 5 units between those 2 points. Okay, so it's just those two concepts. So the first thing was the coordinates. You've definitely seen x and y axis before, okay, and the proper name for that is a Cartesian plane. And it's just to remember to always do the x first and then the y second. and then a distance formula, which will give you the distance between 2 points or the length of a line. Same thing. And this is how you use it. Okay, so I have a couple of practice questions, or actually it's just one question with 4 parts for you to do for Wednesday. All right, talk to you then.